Hello, this is going to be a getting started tutorial for using NES with monogames. So this project is going to assume that you don't have too much monogame experience. We'll assume you're pretty new to monogame. It won't go over too many details of actually using monogame, but like just enough to get people started. So it's assumed at this point that you know where NES is. NES is available on GitHub, user Prime31. And I just did a fresh pull of the repository and I threw it on my desktop, and you can see it here as the NES master. And we're going to take it from there. So this is a plain old default mono game project. I just use the default mono Mac template here. So let's go ahead and run this and take a look at what we have. And oh, look at that. We have an exception. Okay, so I'm going to purposely actually let things break while making this video so that you can see different ways to actually deal with the errors and kind of learn in case you're new to monogame. So this particular error, it looks like we have something going on here with create menu ref, and this is pretty common. And the main root of this is it doesn't have a main menu to work with. So I'm gonna go ahead and take it from the top and show you how to do this. So if you run into this error, the first thing we need to do is create a new file here, and we're going to go to Monomac, and in the Monomac you can see there's a main menu type. So let's just call it main menu, and we'll create that. So you can see we have our main menu zip now. So this, I should also point out, is something you would only ever see on Mac, obviously. If you're working in Visual Studio on Windows, then this isn't something that'll come up. And this is also fixed in the next version of Monogame that comes out. But just in case you run into it, this is how we deal with it. We open up the info.plist, and you can see the main interface is blank. So let's just choose that main menu zip we just created. And now let's go ahead and run it. Okay, there we go. We got the good old cornflower blue screen up. Exactly how we wanted it. Okay, so now we've got a or a plain old mono game project working, so let's actually incorporate NES now. So what we're going to do is we're just going to add existing project. And again, I pulled that NES repository and I stuck it in NES master. And what we're interested here with is the root of NES, which is a PCL project. So PCL is a portable class library. If you don't know what that is, the main gist of it is it's a type of project that creates a DLL that can be used on any platform. So whatever mono game supports, the PCL will work with. So let's go ahead and open it up, and we're just going to do a test build here to make sure everything's functioning, and it's building successfully. Okay, good. So now what we need to do is in our references, we need to reference the NES project so that we can use it. And you can see Xamarin has lets you choose by project. And this is very similar to Visual Studio if you're on Windows. So you go in here and add NES. Now, once we add NES, there's a lot of stuff we can remove now. So let's just delete a whole bunch of stuff. We don't need any of this standard template stuff. Like NES is going to handle all of our game loop, all of our updating, rendering, all of that stuff. So we could remove all that. We'll leave the initialize here so that we can use the initialize method to set up our scene. So next thing we have to do is let we want to actually subclass the core class in NES. So if we go ahead and subclass core, you'll see that it comes up red, and that's no problem. That's just because we're missing the using statement. So we'll let the IDE add that for us. So now we've subclass core, and let's go ahead and run it. Oh, we got something wrong here. It says graphics device manager is already present. And the reason we're seeing that is because NES actually creates the graphics device for us. We don't actually need any of this here. We can remove everything. We can leave an empty constructor. And let's go ahead and run this. And oh, we still have an exception. And what do we have here? Oh, okay. So it looks like it's trying to load the NES default font, but it's not able to find it. So if we were to have actually read the README, we'd see in the setup section here, it mentions that NES needs to have the default font placed in your content NES folder. So let's go ahead and do that. So we're going to go into our content folder here, and let's just create a new folder. Call it NES. And all of the NES default content is conveniently located in the default content folder. So let's drag that bitmap font in, stick it over here. We're just going to add it as a link. We don't need to copy it into the project. And then final step is we just need to tell Xamarin that this is content. So we're going to say build action content. All right, so now let's run it. And we have a black screen. And that's good. We didn't set up the scene, so there's nothing really to render, so black screen is what we'd expect. So one last thing we want to do here is we want to make sure that we call through to the constructor of core itself, so NES's constructor. And this takes in a few optional parameters. You can do set the width and height of your window if you want full screen or not, and by default entity systems are enabled, so you can enable or disable them. We're not going to go into entity systems in this tutorial, but we'll just leave that. It's not going to cause any havoc. So now we are all clear to actually create our first scene. So the way NES is structured is a pretty standard entity component system. Scenes are at the root of everything, and you add your entities to your scene. So before we do anything, we need to create a scene. We can do that a variety of different ways. The scene class itself has two different static methods, has a create and a create with default render. So let's just go ahead and do scene.create, and you can see it takes an optional clear color in here, and we can go ahead and just set that to cornflower blue, and once we create the scene, we need to then tell NES to run it. So core.scene is where we're going to do that. And if you're changing, if you have multiple different levels in your game, menus, whatever, the way you would do this is to create different scenes for them, and then you just set core.scene to your current scene. That's what's going to be the scene that gets rendered. So let's run it. Oh, okay, we got another issue. What's this one? Okay, so we have an assert running here. The assert class is something that's part of NES. This is something you can use in your own classes. If you want to just add in a bunch of asserts so that you can make sure different things are present and expected. The state is exactly how you expect it. The assert class is only going to be compiled into your game when you do a debug build. So it's really handy. You can put asserts all over the place, and when you do a release build, none of them are ever going to get touched. So we can see right here that our assert is saying it's running into this here. There's 0 renderers in the scene. So it says scene has begun with no renderer. So that's because we created scene with the create method. This doesn't actually add a renderer. So if we use the create with default renderer, this will actually, as the name implies, create a default renderer for you. So let's load that sucker up, and oh, there we go. So we have our cornflower blue window. So everything's up and running now. NES is working like a champ, and you're all set and ready to start using it. So let's actually get something displayed on screen now. I'm going to stick a PNG file that I have over here. I'm just going to put it in the project. So I'm going to stick this in here. We're going to link it. And we have moon.png here. And like all content in MonoGame, we just want to set that to be content type of content. And once we have that in there, we now actually have something we can work with. So NES works with, MonoGame works with PNGs, or you can run those PNGs through the pipeline tool and create XMB files. It can handle either one. Now, we'll create a sprite with this now, with that moon PNG. So, as mentioned, scene is the root. That's going to be where we add all of our entities to. So the first thing we're going to need to do is create an entity. So to do that, we can actually just do that right in the scene here. So the scene has add entity, where if we wanted to add an existing entity, we can do that. In this particular case, we're creating one. So if we take a look at this, we can see create entity method will add an entity to the scene and return it. So that's what we want. So let's create an entity, and we'll call it first sprite. So that entity is now in our scene. If we build and run, there's nothing to see. An entity by itself doesn't actually have any visuals associated with it. So what we can do is add a component. So we have the add component method that lets us add various different components. And NES comes with quite a few components. So you see there's an ECS folder, that's the entity component system. And over here, we have lots of different components included with Nez. We have camera shake, follow camera, different ways to display text. Renderables are things that you actually would see on screen. So there's different things like sprites, particles. These are all the renderables. So for our particular case, we just want a simple sprite. So let's just do new sprite. And we'll see we get the good old red splotch again. So if we just do using Nez sprites, it'll add that for us. And let's take a look at what the sprite class offers. Okay, so there's two constructors. We have one that takes a texture 2D, and we have one that takes a subtexture. A subtexture is just a texture that's in a sprite atlas. So it consists of a reference to the texture itself, and it also contains the rectangle on that particular texture that we want to display. Now for this, we're using moon.png, so this is just a single file. It looks like this. So we don't have to worry about subtextures for this. We're just going to create a plain old texture 2D. So let's grab our texture. We'll call it moon over here. And the way we load content in MonoGame, for those who are familiar with MonoGame, you'll know that there's a content manager built in. So Nez extends that content manager and gives it some new features. And also what it does is every scene has a content manager. You can see here that this is a scene-specific content manager. So what that means is when we use the scene-specific content manager, when we load a new scene, it'll automatically unload all of the content from the scene for us. So we're going to go ahead and just do the standard load method. Again, if you're familiar with MonoGame, you'll have seen this before. If you're not, the way the load method works is you tell it what kind of class the content is that you're loading, which for us is a texture 2D, and then you tell it where the file is. And in our particular case, moon is just right in the content folder. So all we have to do is tell it that we want the moon texture. And the sprite, remember, needs to know about the texture, which is called moon. Okay, so now we have a scene. We added an entity to the scene, and we've added a sprite component. Let us run this and see what we end up with. Oh, there we go. We have our moon. So our moon's by default is displayed at 0, 0, which is the top left of the screen. So that's not all that useful. So let's move that somewhere. So the entity, the way you place your entities is via the transform. So this is standard transform. Like you'd see in most game engines, it consists of your rotation, your scale, and your position. In this particular case, we're only going to care about position, and we're just going to set that somewhere where we can see it. So I'm just going to go ahead and make it 400, 400. So that'll push it off from the screen somewhere so it's not hidden up in the top left corner, and there it is. All right, so just like that, we have Nez up and running. We have our first scene running. We created our first entity, and we added our first component to it, which is the sprite. So that is the core basics of Nez. Now, let's take it a step further, and let's actually add a sprite animation. No 2D game out there is going to exist without sprite animations. Nez makes sprite animations pretty simple. So Nez includes different pipeline tool content processors. And if you're not familiar with those, we'll go into them. So let's just start by opening up this content. So by double clicking on the content MGCB, this opens up the pipeline tool. Pipeline tool is a built-in bit of MonoGame, and it's a takeover from XNA, where it's a tool that lets you pre-process your content. Like, for example, if you had 3D models or textures or sound files, you would use the pipeline tool to pre-process them. So let's set up the pipeline tool first. So by default, it's going to choose Windows as the platform, even though we're on OS X. So let's just change that to OS X. The profile, you have two options, reach and high def. You'll want to use high def. Reach is just the kind of thing that it's basically only useful if you're using Windows Phone at this point and targeting Windows Phone 8, which nobody is, so it's not a problem. And that's it. So our content project's set up. So right now the pipeline tool doesn't actually know about anything Nez related. So let's set that up. So Nez has a separate project that we're going to add. So we're going to add it the same way. We're going to choose Add Existing Project, and right in that repository we pulled, you can see there's a pipeline importer project. So let's go ahead and just add that CS proj file. And it might take a second for this to load because it has some NuGet references, and these look like they're already loaded. So we can go ahead and do a build on this and see what we get. Oh, we got some errors. So what's going on here? Doesn't have access to nes.textureatlases. Okay, that makes sense. We actually didn't add a reference to Nes, so let's do that. So in here, when you add reference in Xamarin or Visual Studio, you'll have your local projects available to you, and you can just click the checkbox, click OK, and now we can build it again, and you can see the error goes away. Everything's happy. So we've now just built the pipeline importer project, and you only have to do that once. Once you do it once, it's all done. So let's see what we've actually created from it here. So if we go into the bin folder, you can see we have a bunch of DLLs. And what we're interested here is the pipeline importer DLL and its requirements. So we're done with the pipeline tool for now. So we have to go into our actual pipeline tool application here, and we need to now just let the pipeline tool know about these assemblies that we just built. So the way we do that is standard references, just like we were setting up in a standard project. So if we open this up, we get a little selector here, and we want to just go to those that we built, which are in the pipeline importer bin folder. So if we go in here, the ones we're going to want: pipeline importer, the JSON library. JSON is used for texture packer, so Nes accepts texture packer files by default, and we're going to want zlib also. Zlib is used for tiled maps. If you do compressed tiled maps, it'll need to decompress them. So that's what that's there for. So if we add these references, click OK. Now we have to actually close down the pipeline tool and reopen it. And reason for that is the pipeline tool only loads those DLLs at launch time. So now we have the pipeline tool set up and ready to roll. So we want to use a texture atlas. And texture atlases in Nes are handled just via folders. So if you have, I have this textures folder on my desktop, and you can see inside of it there's a hard landing folder with a bunch of different sprites. And what we need to do is just tell the pipeline tool that we want to create an atlas from all of the PNG files that are in the textures folder. And one added benefit here with Nes that it'll do is it'll actually, any subfolders that you have, for example, this hard landing one, it'll create a sprite animation automatically for you for each subfolder that it finds. So let's go ahead and set that up. So the way Nes works with texture atlases is explained in the wiki. There's going to be tutorials, more tutorials added to the wiki, but in the controlling rendering section, it goes into the details of how it actually works. We'll set it up. We're not going to go through all the little nitty gritty. We'll just actually do it. So if we go over here, we're going to say add new item, and it uses an XML file to identify things. So let's call it first atlas. So we create this, and you can see we have our first atlas XML file. Let's open it up. And this is a standard XNA XML file. This is what it'll look like by default. By default, its type is object. We need to change that to system.string_array. So we're using a string array because what we can do here is for the items in the array, we can choose to specify our textures individually. So that would be like this, for example. This is specifying individual textures, or we can just give it a folder. In this particular case, that folder is just textures sitting on my desktop. So I'm going to just use a full path to it. Under normal circumstances, you'll most likely have your image files in your content folder here. But just for ease, I'm just going to use this. And if that textures folder happened to be in our content folder, we would just specify it relative to the content folder. Okay, so that's it. This is set up. It now knows that it should take all the image files it finds in that textures folder and create an atlas from them. So the pipeline tool, the way it works is it has importers and processors. The importer is what reads in the data file, whatever it might be. In this particular case, it's an XML file. In other cases, it might be a tiled map file or a texture. So for this one, XML importer is fine, but the processor is what we have to change. So if we open this up, we see there's a bunch of different processors here that are this default ones that are monogame, and then there's the rest of them which are NES. So the one we want is the texture atlas generator. So if we choose that, we get a couple options. We can choose to compress the texture and set the animation in frames per second. We'll leave the default values. You can change those at runtime, of course, as well, but those are just setting up the default for the animation. So now that this is set, we can go ahead and run the rebuild, and you can see it spits out some data about the process here. So it's letting us know that it's adding a hard landing animation, and it's letting us know each of the textures that are being added to the atlas. And then it'll tell you how many sprites it packed and the full size of the atlas when it's done. And here's the important line. We always want to just make sure that the build succeeded. If there are any exceptions in the process, then they would show up here. Okay, so let's just remember the name here. We have first atlas is what we called it, because that's how we're going to identify it when we go to load it. So let's load up that atlas. And we're going to use the scenes content manager again. And we're going to choose load. And what we want to load is a texture atlas. That's what it is. So when we do this, we see it's not getting syntax highlighted. And that's, again, we're just going to need to add that using statement. And now we need to tell it where to find that atlas. And we take a look in here. Actually, let's reopen this. So by default, the pipeline tool will spit out in its output directory field here. You can see the output directory is bin and then platform. So our platform is Mac OS X. So it's going to spit them out in bin Mac OS X. So let's go ahead and pop them in there. So that's the full path to it. Let me just double check and make sure we actually did call it first atlas. There we go. Okay, so that's going to load up the texture atlas. So let's grab the animation out of the atlas. So the way we do that is we just do atlas dot, and let's take a look at what we have available here. So using autocomplete is by far the best way to learn a new system, in my opinion. It's just such a quick, easy way to do it. NES has summaries for just about everything in it. And what we want here is we want a sprite animation. So we can see here, if we read the summary for sprite animation, it returns a sprite animation if we tell it the animation name, which is the folder that contains the images. Just in case you forgot, the folder is hard landing. All right, so that's it. We loaded up the animation. Let's run it and see what happens. Oh, okay, we got to crash it. So we have a content load exception. Just like when we saw that with the default font, that almost always means that the file wasn't available. If we just want to dig into the exception a little bit, we can have a look and see, and it says, oh, okay, the directory wasn't found. So why wasn't the directory found? That sure is odd. Let's actually take a look and see why. Okay, so we're looking for the bin Mac OS X folder. Now, I believe this is a monogame bug. On Visual Studio, this will actually work properly, but by default, monogame won't actually add your compiled content. So let's go ahead and take a look in the debug folder. So this is where our compiled game is. And if we look here, we can see that there's no content folder. So monogame will actually just create a content folder here when it actually, for all the stuff that it compiles and puts in there. So what we could do is we could go into content here, and we could do add existing folder, and we could add the bin folder. But let's not use a band-aid. Let's actually fix the issue. So what we're going to do here is a little trick. I'm going to go ahead and open up the CSproj file. So this is just plain old CSproj file, and just go down to the bottom right before project. And what we're going to do is I'm just going to copy paste a little goodie here. So we're going to add a new item group. And all this item group is saying is add as content anything in the content bin folder and all of its subdirectories. So now, if we shut that down, we'll see when we switch back to Xamarin, it's actually going to reload this, and you'll see it'll just, oh, there it reloaded. Okay, so it's asking about Xamarin Mac. Let's just, don't ask me, we're going to use MonoMac. And it reloaded the project. So now I'm just going to do a build, and if we go over here, oh, take a look, there's the content folder. So now you can see we have content, bin, Mac OS X, and there's First Atlas. So that particular little folder is what we use for debugging issues like this. If you ever add content, be it textures, audio files, whatever, and it's not loading, just make sure that it ends up over there. So now if we run this, we have no errors. We have no animation displayed, but that's okay. All we did is we created the sprite animation, but we didn't actually add it to anything. So let's add a new entity. So we'll call this one entity 2, and again, we're going to create it on the scene, and this will be our anim dude. So what we're going to want to do next is add a sprite component so that we can display it. So entity 2, add component, and we're going to say new sprite. Now, if we remember, the sprite class took in a subtexture or a texture. It's not exactly what we want now. We're dealing with animations. So we're going to actually be dealing with the sprite T class. And the sprite T class as a standard generic component. And what that generic component is it lets you identify your animations. So whatever you choose there is going to be how you tell Nez which animation you want to play. So in the example in the wiki, you can see this is the line where that happened. And in that particular case, we used an int, and we just chose the particular animation as 3. So you can add as many animations as you want, all with integers. In a full-blown game, we're going to want to do things a little bit smarter than that. So instead of an int, let's use an enum, which makes more sense. So we'll call it animation, and we add hard landing was the name of our animation. Now you'll probably have other ones. You'll have your idle animation, your run, walk, whatever. You add all your animations here to your enum, and now we can use this animation enum in our sprite. So let's go ahead and do that. So we can say sprite, and we're going to use animation as our key for the animation. So let's look at the constructor now. So now we have 3 options for the constructor, and you can see this third one here lets us set an animation key along with our animation, and that's exactly what we want. So we're just going to do hard landing. And the actual animation that we want to use for that, we loaded just a second ago, and it was called anim. So now, let's just move our entity a little bit, because remember, by default, the entity will actually be way up in the top left corner. So we'll just move that somewhere visible. So let's move it to 100, 100, and let's run it. All right. Okay, so what we have here is nothing. It's not animating. It's sitting there idle. And by default, Nez isn't going to play an animation for you. You actually have to tell it what to play. So what we're going to actually do here is learn a little bit more about how Nez's entity component system works, and we're going to play that animation. So we added that component, and we have this sprite animation component now. So let's go ahead. We're just going to copy that in here, and we want to actually gain access to the component that we added. And we can do that in a variety of ways. We could have created this component and just set it as an instance variable or just field there or property or whatever. But there's going to be times where you have your entity full of components, and you're going to want to pull those components off the entity. So the way we can do that is we'll just create a new variable for it, and we're going to say entity2.getComponent. So you have 2 variants here. You have getComponent and getComponents. GetComponent will return the first component of type T. GetComponents will return all of them. This particular case, we have a single sprite animation, so we're just going to fetch it. So now we have access to the sprite, and we can say play, and you can see now you will use that animation key that we created. So let's say if we had added 4 animations, the hard landing, idle, run, and walk, we can choose which one it should play at any particular time by just calling play and specifying. So let's go ahead and run that, and you can see we have our animation running. All right, so that's it for this getting started tutorial. Just as a recap, we went over creating a scene, adding entities to the scene, adding components to our entities. We learned how to create sprite atlases, and we also learned how to use textures directly. So that's a huge amount of what you're going to be dealing with in a 2D game covered already. Future tutorials will go into some stuff in more detail. But that's it for now. Thanks for watching.